Hello everyone, welcome and good evening to all of you. So guys, you are watching me on Unacademy Live, the CSIR NET channel of Unacademy, and we are having another YouTube quiz. Now this is our third YouTube quiz session. Alright, we have already had quizzes, live quizzes on the topics of aromaticity as well as stereochemistry. Alright. So these two topics are already covered in the YouTube quiz section, and today we are going to discuss questions, previous year questions of reaction mechanism, right? So I have taken some mixed questions from CSIR NET as well as GATE questions. Alright, all of you guys, so I hope that all of you can hear me properly. Yes, everyone. Hello Dinesh, Ekta, Sunil, PK, Deshini, Ganesh, Akshay, Sunil, Sheetal. Hello everyone, and a very good evening to all of you once again. Yes, right? Okay, so now we are going to start our session, and before moving onwards, as always, if you haven't yet joined me on Unacademy, please do guys, because I provide a lot of free content as well as a lot of content on Unacademy Plus as well. Now Unacademy Plus is a paid platform, and it's okay if you are liking the content, then you can join me on Unacademy Plus, and in between the session I am definitely going to inform you how to join Unacademy Plus. Alright, and what are the courses. Alright, so we conduct courses, different courses on Unacademy Plus. Complete course, one complete course is a one complete package on a topic. So let's say if we are doing organic reaction mechanism, that means we are completing the whole of organic reaction mechanism along with practice questions as well. Alright, so I am teaching for CSIR NET Chemical Sciences, and you can join me on Unacademy Plus by using this code JagritiSLive. Alright, a very good evening to all of you once again, and now we start with our first question. Yes, here it is guys. The product A and B in the following reaction sequence are, now this is our first question and this is a previous year question of June 2014. So I am going to give you 2 minutes to be able to answer this question, right? It's a very good question guys, don't take more than 2 minutes for this. Hello everyone. Hello Akshay, Lucky, Simran, Vilas, Pavan, Dipti, Dinesh, welcome. Yes, what do you say? Alright. Okay, so I want all of you to answer in the live section. If you are watching this session, then do answer in the live chat, guys. Yes, this is our interactive session, isn't it? Yes. Alright. Alright, very good. So what is this reaction first of all? Now we have triethylamine, and along with that we have carboxylic acid, and we have this molecule over here in which we are having two leaving groups. We have a methoxy leaving group and we have a chloride leaving group. Very well. So in this kind of a question you might get confused that, let's say, even if somehow, even if your proton is being lost from the carboxylic acid, the triethylamine is a base and there might be acid base reaction, and the carboxylate is going to attack over this carbonyl carbon, the bond opens up, falls back. Now who is going to leave? The chlorine is leaving or the methoxy is leaving? Yes, who is leaving guys? How do I know that? So Cl minus is a better leaving group as compared to the methoxy. Yes. All right. So yes, Cl minus is a better leaving group as compared to the methoxy. And why is that so? Because if we compare the pKa values of HCl, which is very high, sorry, very low value, it is less than 0, and pKa of methanol, yes, it is approximately around 16. So definitely you can see that HCl is a very strong acid. If it is a very strong acid, then the conjugate base is going to be a very weak base, and it does not, it wants to stay free. All right. So that is why lesser the pKa of the acid and better the leaving group it is going to be. We have already had a discussion on this. You are going to get a special class. We had a special class, right, on the pKa concept. pKa concept, definitely you can watch it, guys. Now we come back onto the same question. What do we see? That triethylamine, is it only working as a base? Yes, Vilas, definitely I have addressed your question and we are working on that, don't worry. Yes. All right. So is it only working as a base, the triethylamine, or what is it doing? The trimethylamine is also replacing the chlorine. It is also working as a catalyst. It is replacing the chlorine. All right. And now the carbonyl carbon becomes even more electrophilic because there is a positively charged nitrogen connected to it. Further, it is a good leaving group, so you get the coupled reaction. All right, you get this coupling reaction right over here. OMe. Now further, yes, this is what you get. Now further, you have an amine, you have a primary amine attacking over which of these two carbons? Now which of these two carbons is more electrophilic? Yes. Alright, so which of these is more nucleophilic, more electrophilic carbon, guys? Definitely this is the more electrophilic carbon, because here you are getting resonance from both of these oxygens. Okay, so that is why this carbonyl carbon, it is getting electron density from both of these oxygens, and this one only with one oxygen. So it is more electrophilic carbon, and that is why when the bond opens up and falls back, you are going to get this product. Alright, so this is your major product, option number A. Very well done. Yes, so now we move onwards and we move to the next question, guys. Here it is. The major product formed in the following photochemical reaction is. Now this is a June 2014 question. Okay, so what do you think is the correct answer from A, B, C and D? Yes, everyone tried it out. So what do you see, guys? Tosyl chloride, is it? What is the first step? Yes, very good. Alright, so what is the first step over here that we see? The first step might be the formation of tosylate functional group. isn't it? The alcohol, it is having a proton. The proton is going to be taken up by pyridine, and after the removal of the proton, you are getting the attack on the tosyl group, which has a chlorine good leaving group. So you are first of all getting the tosylation of the alcohol. Then secondly, what do you observe is the tosyl group is a good leaving group, isn't it? And if it leaves, you are going to get a carbocation. So either you can consider the mechanism like this, that okay, a carbocation is formed and one of the bridging carbon is migrating. Why is it migrating? Because after it migrates, let me just draw the molecule in the same pattern so that you understand clearly what just happened. Okay, after it migrates, you are getting the ring expansion. This was a very small ring over here. Okay, and now this is a bigger ring. So the ring expansion is the driving force. Right, the ring expansion is the driving force for this reaction to happen, and you can also write this intermediate like this, which we usually do. Now it has two carbons on both the sides. Yes, right. And you have a positive charge, a carbocation on the secondary carbon right over here. Now what do you expect? Since there are two bulky methyl groups, the tosylate, even though the lower part is also hindered, but the upper part is even more hindered, right? These faces are even more hindered, so definitely it is not going to attack from this side. So your product is definitely going to be like this. Yes, so this is your product, option number B. Or if you want to consider it, then there is one more thing that you might understand through that the group which is migrating is anti-periplanar to the leaving group. Okay, so the migrating group is anti-periplanar to the leaving group. That is the best position to migrate, isn't it? Here it is like this. The migrating group is trans, or let's say anti-periplanar to the leaving group, right? So directly migration is going to take place, and this is what you get, your major product. Alright, very well guys. Now we move on to our next question. The major product formed in the following reaction is. June 2013, we have a very nice question coming up. Hello Arunima, Vishnu, Sunil, Kirtana. Welcome guys. Spandan, Deshini, Shankar, Reema, Pooja, Pavan, Lucky. Welcome all of you. Hetal. Yes, definitely it is. But what is the correct answer, Vilas? Exactly, it is the push-pull mechanism. Are you able to see that this is a trans decalin system? The OH is below and the H is above. Alright, so the OH is below, the H is above, and the tosylate is on the next carbon, which means if it wants to be above the plane, it has to be equatorial, isn't it? Ye equatorial hona padega, right? Now you have a hydride base. The hydride is going to, yes, the hydride is going to deprotonate the oxygen, O minus. It is below the plane, okay, and the hydrogen is above. Further you have the tosylate like this. So definitely it is the push and pull mechanism, as you can see guys, because the O, or let's say the O minus, can form a double bond with the carbon, which is a more stable bond, and further this bond, which is again anti-periplanar to the tosylate leaving group, this bond is again anti-periplanar to the tosylate leaving group, and that is why it's easier to break this bond and form a double bond like this. So drawing the molecule in the same pattern so that you correlate nicely. So what is the stereochemistry of this bond? As you can see, because there is a hydrogen which is in the axial position. Yes, so you can say that this bond is a trans bond. This double bond is trans, or the E alkene. So let's look into the product. In option number C, alright, you can displace the carbonyl group. You can just change the position of the functional group if you are changing the position of alkene, alright, but just take care that they are equally distant. But here we are having the cis double bond, that is why it is wrong. Option number D is correct because here we have E bond, alright, or the trans bond. Definitely it is correct. Yes, very good all of you. So A and B are completely wrong because we are having push-pull fragmentation. Very popular reaction, guys. Very popular reaction and very easy as well. Now we move onwards. Yes, just let me answer your question, Sunil. So you were saying that if the stereochemistry is different, then what is going to happen? So let's say you are saying that the stereochemistry of the OH is like this, isn't it? It is a cis decalin system. Alright, now if, yes, if it is a cis decalin system, how are you going to write it? Let's say you write it like this. Okay, there is your hydrogen, there is your OH group, and there is your OTS once again. Now if you want to draw the same mechanism once again, it is possible only in this case because, yes, because what you want is you want this bond to be anti-periplanar to this one, isn't it? The bond which is breaking, this is O minus, let's say proton is being taken away, O minus. This reaction is going to be a little bit slower. That is for sure. The reaction is going to be very much slower if we have taken the cis decalin system. Much slower reaction as compared to the trans one. Here the push-pull mechanism is fastest. Is very fast. Alright, because of the proper geometry. Yes, here it is going to be a little bit slower. Yes, alright. Now we move onwards and we see, guys, a very important reaction. The product A and the product B in the following reaction sequence are, this is a December 2014 question. Yes, Sunil, definitely. Alright. So what do you think, guys? It's a very beautiful question that we have over here in the reaction mechanism part. So there is a lot of selectivity in this question. I hope that you can see the question properly. Yes, is the question clear? Yes, everyone reply. Guys, everyone comment in the live section. Alright, yes guys, so we move onward and do this reaction. So whenever you have TBAF, what is TBAF? It is tetrabutyl ammonium fluoride, isn't it? It is tetrabutyl. Definitely it is going to be a tetrahedral structure. I've just randomly drawn it. It is not square planar. So basically it is again a phase transfer catalyst in the plus class only. Today only I have explained the 18 crown 6 and the TBAF. All of these are phase transfer catalyst. Alright. Now what are we able to see, what are we able to observe from this reaction is that first of all, yes, first of all we are having the silicon. Do you see that there is a silicon group over here? And you know already, we have seen this in a lot of time in the Peterson reaction and so on, that silicon has a huge affinity for oxygen and fluorine. Yes, alright. Now if let's say we have the fluoride anion and acetonitrile, this is our acetonitrile, this is just solvent, okay, and there is going to be elimination like this. The F minus attacks over silicon and the bond is going to open up and fall onto this carbon. Now this selectivity is that where is the negative charge going to stop, because just as you can see, the negative charge can undergo resonance. It can undergo complete resonance till the nitrogen. Alright, so that is the question, and that is how all the different options are given. So let me explain to you that okay, the F minus has attacked over silicon and let's say the negative charge fell over this carbon. Then you are going to have a species like this. Alright, there would be a negative charge on the primary carbon. Alright, now you have one option which has directly, okay, so in the second step you have an electrophile. What is the electrophile? The electrophile is that there is going to be an attack on the ester carbonyl over here and the bond is going to open up like this. Okay, so you have an electrophile. So now from where is the carbon attacking? Is it attacking from directly onto this carbon? Then it gives you a product like this. Option number C. Direct attack from this carbon gives you a product, option number C. Okay, but that is definitely not possible. That is not possible. Option number D is again completely wrong, because here the attack is taking place onto this carbon, which is again wrong. There is no, this connectivity cannot be defined. Okay, option C is wrong because the negative charge is not stable as such. So what are we going to do? Are we going to do resonance? If let's say we do resonance further, then the negative charge can stop at this carbon also, isn't it? It can stop at this carbon, and let's say the intermediate is like this. Alright, so let's say the intermediate is like this, CO2Me, and there is a double bonded nitrogen, SPH. Okay, so let's say the negative charge has stopped on this carbon and from this carbon it has attacked on the electrophile. Then you get product number B. Then you get product number B. But again, when you have conjugation possible, when you have complete conjugation possible throughout, then the negative charge is not going to be localized at any one carbon in between the whole conjugation process. So both B and C are, that is why, wrong. If we are doing option number A, why is it correct? Because now the negative charge is completely going to do the resonance. It is doing its complete resonance, and that is why, yes, and you have something like this. Okay, I hope that you can see. Alright, let me raise a little bit. So if there is a negative charge formed on the same carbon, it is going to delocalize, and to the nitrogen it is going to give the electron density. Alright, sorry guys, there is no double bond over here. There is a double bond right over here and over here. and the negative electron density on nitrogen. Now this is the correct resonance structure, and this is going to attack on the carbonyl carbon like this, so that you get your molecule. Now this is the product number A. This is the product number A, alright? Yes, exactly. Extended conjugation is definitely going to take place. Further, there is one more thing. In the second step, you have heat. What is the heat going to do? Let's check out. So guys, you have a diene and you have a dienophile. Alright, so what is possible in the presence of heat? Tell me. What is possible in the presence of heat? Four plus 2 cycloaddition is possible. Yes, the Diels-Alder reaction is possible. Yes, the Diels-Alder reaction is possible, and further I have already explained this to you. It's a very beautiful question. So whenever you have the hydrogen over here like this, then the stereochemistry, alright, you just have only one Diels-Alder product, so definitely this is our only possibility. For over here, for this molecule, you just have to see that whether are you getting a Diels-Alder possibility, and yes, there it is, only one Diels-Alder product, so you don't have much to see. Just have to see where is the negative charge ending. This is your correct nucleophile, the nitrogen, and further a Diels-Alder reaction has happened to give you B. Alright, so this is a very nice question, and the answer is option number A. I hope that you try it out by yourself. It was asked in December 2014. Now guys, I have a lot more questions to be discussed, and we have the session till 10 p.m. so we are going to discuss a lot many questions. And before that, let me quickly tell you that a lot of new courses are going to be launched from the month of October. What are those courses? There is going to be a revision course, there is going to be a previous year question course, there is going to be a inorganic chemistry course, and along with that there is going to be a revision course on the organometallic and bioinorganic as well. So a lot of new courses along with a lot of MCQs are going to be starting from the month of October. But the thing is that since that is going to be revision, if you haven't studied with us, you won't be able to follow the pace of our revision. So that is why I suggest you that if you already haven't joined the Unacademy Plus, please do. These are all the topics that we are studying: stereochemistry, reaction mechanism, reactive intermediates, spectroscopy, pericyclic photochemistry. So basically I am covering all of the organic chemistry. Along with that, I am taking the major portion, the major scoring portion, the organometallics and bioinorganic. In the inorganic as well, I'll be taking coordination also, and in one batch course only you are going to get everything. Also, one CSIR subscription gives you access to all the educators. It's not that if you are taking the subscription through my code, you are not going to get the access to other educator. All the educators, including aptitude, is all you require for your CSIR preparation. So you are having doubt solving sessions, quizzes, mock tests. There are mock tests in the Plus also, and you can access to all the mock tests even if you have not given them live. Okay, and guys, if you are joining Unacademy Plus, join for some time. Take some time for the guidance to be given to you properly, so that you can work hard properly, you can get the content properly. Alright, so either come for 6 months, or if you are planning for GATE 21 or let's say June 2021 examination, then you can come for 12 months. Also, if you are in your MSc, this is the ideal package for you. If you are in your BSc, then you can come up for the 24-month plan as well. Alright, and don't forget to use the code JagritiSLive. Alright, this code gives you a 10% discount, and along with that also use your credit points. Okay, and yes, this is how you're going to get your discount. The prices are going to be reduced only after using the code. And yes, don't forget, you are going to get access to everything on Unacademy CSIR category. So another question, from GATE 2005 paper. The compound formed on methanolysis of P is Yes, Shubhangi, what is the role of MECN? MECN is basically acetonitrile and it was just working as a solvent, polar solvent, okay? The compound formed on methanolysis of this molecule is Alright guys, what do you say? This is a very simple question. Till now all of you must have answered. Alright, very well done. So yes, definitely when we are doing this question, yes. So whenever you look at a molecule like this in which you have a, you know, this carbon, which you also can call the anomeric carbon, right? That term we use for the carbohydrate, but basically the concept is the same. Because of the conjugation through oxygen, the Cl becomes a good leaving group and you have the intermediate oxonium anion. Okay, and that is why the methanol is going to attack on the same carbon. So here the oxygen is behaving as an internal nucleophile, isn't it? Yes. And your correct answer is option number D. Definitely guys, very well done. Yes. So D is your correct option and not B. B is not going to be correct because when you have a leaving group close to an electron donating group like this, then definitely the substitution takes place at the same carbon. Alright, so your answer is option number D. We are going to move onwards to this question. The major product P of the given reaction is, again a GATE 2005 question. Alright guys, so what do you say? What is the topic that we are doing the question for? Yes, what is the mechanism? Can you tell me? Is it substitution? Is it NGP? What is it? Yes, very nicely answered guys. Very nicely you're answering. So definitely it is the elimination. Which elimination? Now you have a strong base over here, isn't it? You have a strong base and along with that you have a good good leaving group as well. And you already have the anti-periplanar geometry. Very good. So you already have the anti-periplanar geometry which is required, very good guys, which is required for the E2 elimination reaction to happen. Okay, so yes, you are all correct, and the double bond which is formed is going to have this substituents. The substituents, both of the methyl, are going to be on the same side, the phenyl and the hydrogen, which are basically both below the plane. That is why they are on the same side. Okay, why is this option number A wrong? Because here you are having the methyl trans, which is not possible. Both of the methyls are on the same side. Okay, and because the anti-periplanar position is already present, you don't have to rotate the molecule or make any conformational changes, and that is why you are having directly both the methyl on the same side. So answer is option number D. Very nicely done guys. And since this is a strong base present, we are not having the substitution reaction over here, and neither are we having the Hofmann elimination. No, we are not having the Hofmann elimination that we would have had. Hofmann elimination would happen if we had a bulky base. For example, if we had the tertiary butoxide base, then we could say that it could be the Hofmann elimination, not here. Alright, very good. Moving onwards, this is a very nice question once again. Correct order of the rate of solvolysis for the following chlorides in the acetic acid is. Now, it's a very nice question. The rate of solvolysis it asked. Alright, so what do you say guys? So the correct rate of solvolysis is going to be like this. Now basically guys, solvolysis is just the reaction of the alkyl halide with the solvent. Let's say following chloride in acetic acid. Now if the acetic acid is the solvent, then definitely there is O minus which is going to attack the alkyl group, and there is going to be inversion, and this is what you are going to get. Now it does not depend whatever the solvent is, solvolysis is going to be faster if anyhow or somehow the carbocation is stabilized, isn't it? Yes, the solvolysis is basically your SN1 type reaction. Okay, and it is going to be faster if the intermediate is going to be stabilized. So what do we see over here? Now when the chlorine is leaving, when this chlorine is leaving, then what do we have? There is a positive charge on this carbon. Now that positive charge could be stabilized by this oxygen. Alright, and that is called the NGP. Neighboring group participation. Very well. Yes. Now the NGP is giving you how many membered ring? Let me just write it once again guys, so that we check a very important factor over here. What is the important factor? Okay, oxygen is going to get a positive charge, very well, but 1 2 3 4 5. Alright, so this is a 5 membered ring which is forming. 1 2 3 4 and 5. 5-membered stable ring is forming in this case. However, you also have an oxygen in this case as well, in the second case as well. So you can say that there is going to be NGP once again. But what is the intermediate that you get? And is it more stable or less stable? So definitely guys, as you can see, you get a 4-membered ring over here. This is also doing NGP, but because the intermediate is less stable because of a strained ring, here we are having a strained ring. Alright, and that is why, even though it is faster than 1, which does not have NGP, no NGP over here, so it is going to be faster than 1, but it is lesser than 3. So can we say that 3 is going to be fastest solvolysis as compared to 2, as compared to 1? So our answer is option number B. Very clearly we can see this. Very nicely answered, all of you guys. And here we have another very good question. Very nice question guys, GATE 2014 question it is. And this is a selectivity question basically. The major products X and Y formed in the following reaction sequence are okay, what do you say about this question? Alright guys, so very nicely you are answering. Yes, can you see properly the question? It is methanol and H2SO4 in the first part, and in the second part it is carboxybenzyl chloride, only one equivalent in the presence of a aqueous base. Yes, it is CbZCl definitely. So you can see that there is some protection. Definitely. Alright, so what do we see guys? We see that in the first reaction we expect esterification. Now this is a proper esterification reaction, isn't it? Yes. Right, so it is esterification in the first step, and you already know carboxybenzyl chloride is a protecting group for the amines. Alright, it is used to protect the amines as well as the amino acid nitrogen group. Alright, so CbZCl, the carboxybenzyl chloride, is very popular for doing that. So first step is the esterification reaction with the methanol. So you are going to get the ester like this, okay, not the acid. Alright, further what do we see? Further we see that there is nitrogen which has just got protected. Alright, so your answer is option number B. Not answer is not option number C, because oxygen is not going to oxygen is not going to react with the CbZCl, because nitrogen is a better nucleophile at that. So this is completely wrong. And once again, as you see, oxygen is connected to CbZ. Not at all. The CbZCl is a nitrogen protecting group. Alright guys, so we have solved a lot many questions today and it was very good, and I hope that you also liked this session. If you did, then please tell me in the live chat. And also guys, what are we having next? Ye dekho. What are we having next? We are having spectroscopy quiz tomorrow. So tomorrow I will be taking questions from the UV visible, from the IR, from the NMR, as well as from the mass spectroscopy. So I will be taking questions which is including all of the organic spectroscopy and structure determination. So tomorrow's quiz is 30. Tomorrow is 13th and the quiz is again at 9 p.m. And I hope that you have already visited my quizzes aromaticity, stereochemistry, and today was organic reaction mechanism. Saturday and Sunday 9 p.m. I'm going to see you all. Yes guys. Alright guys, so definitely we have a lot to talk about, and the upcoming quizzes are pericyclic quiz, main group element quiz, and coordination quizzes. 2 coordination quizzes I'm going to have, and already we have had 4 infrared spectroscopy sessions. And guys, just in case if you are not following my special classes, please do, because we are talking about a lot of stuff in detail. So we have studied all of the UV visible and IR spectroscopy in detail, which is getting asked in your CSIR exam, which is good enough for your CSIR exam. Alright, we have one more session which we are going to have on 15th of September, more previous year questions, more practice, and all of these sessions are free. All of these sessions are free. The previous YouTube sessions are free, the special classes are all free. Okay, and as you can see, I'm having 9 sessions on the practice, on the organic reaction mechanism. Okay, yes guys, I hope that you are going to attend all of these sessions, and I hope that you are liking these sessions as well. And I hope to directly see you on Unacademy Plus, because as I told you, it's never too late to start, but you don't have to lag behind either. And we are talking about a lot of good content and a lot of guidance you can get on Unacademy Plus. Alright, along with the doubt solving sessions, along with a lot of access under the CSIR category. So yes, if you want, then don't forget to use the code JagritiSLive. Okay, it's my name, JagritiSLive. That gives you a 10% discount. Alright guys, thank you so much for staying up, and also visit the description below. Don't forget to visit the description below, because there are a lot of important links that you are going to get. Alright, and also guys, do like this session and also share it. I hope that your friends are really going to like it, really going to benefit from this session. So please do share. And once again, thank you so much guys. I'll see you tomorrow 9 a.m. on Unacademy Plus. Alright, and yes, I'll take a leave now. Good night. Bye everyone. Alright guys, bye.